Hi, I'm Stefania Soldini from the University of Liverpool. I'm lecturer in aerospace engineering, and I design guidance and navigation software for satellite. For the past 3 years, I've been working on a real-time mission called Hayabusa 2, which is the Japanese sample and return mission to asteroid Ryugu, a very exciting experience. Today I'm going to talk about a new project, Origami solar sail technology for next generation of self-reconfigurable CubeSat, which is a project that has been recently funded by EPSRC Network Plus within the Connected Everything Network. My partner are JAXA and Oxford Space System, and my CoI Paolo from our robotic lab at the University of Liverpool. So imagine, so today I wanted to talk about a beam-inspired approach towards space exploration. So imagine a small satellite that can work like ant colony and explore our solar system. They can coordinate to achieve specific tasks and finally reconfigure for solving a specific problem. Now, the biggest challenge for a space industry is how to make space mission adaptable and reliable. We think the answer stay in a beam-inspired approach towards space exploration, where a swarm of self-reconfigurable mini satellite, which we call CubeSat, can coordinate together. Now, the good news is in 2018, NASA Mars Insight mission has actually successfully tested CubeSat and they in a Mars, let's say Mars exploration, and they show that it was an important asset for deep space exploration, opening towards a new use of CubeSat also for deep space. Now, the question we have here is how can the next generation of CubeSat perform multiple tasks? And we think that the answer lies in Miura-Ori origami. So Dr. Miura basically invented this, let's say, this specific pattern of creases that allows like parallelogram structure to collapse and unfold in a single motion. Now, if this you think that is kind of a new approach, actually Dr. Miura proposed that for the deployment of solar panel for spacecraft. And until today, the way in which we fold and unfold solar panel for satellite follows the Miura-Ori origami principle. Now, there is another example of successful origami deployable structure in space, which is solar sail technology. What is a solar sail? Now, solar sail, they are lightweight, ugly reflecting membrane propelled by the sun radiation. So if you want to think about an analogy, solar sail are similar to, let's say, sailing boat for Earth applications, where the wind actually push your sailboat and then you can go anywhere in the open ocean. Similarly, in space, we have solar sail technology that uses sun radiation to propel itself without the use of any fuel. Now, this has been successfully tested by JAXA in 2010, which was the first solar sail demonstration mission called Icarus. Now, the idea is, okay, we have this solar sail technology. The question is, can we enable self-reconfiguration using solar sail technology? And this is where our project come into play. So we want to explore next generation of solar sail, not necessarily for propulsion, but to trigger the reconfiguration of satellite. So to have satellite that can change their shape and then can be multi-operational. And how do we trigger that? We think with solar radiation pressure we can do that. So, but before going detail to that, let's look at what are the major components of a solar sail. So they are highly reflecting material. So in blue, you can imagine an aluminized membrane. We have solar array to generate power, but also we have what is called polymer dispersed liquid crystal here in orange. What are they? They follow a technology which is very similar to sunglasses transition lenses. So basically, this is when they are this device is on, it reflects the light radiation, and when it's off, instead, it reduces the effect of the light of the solar radiation pressure. So it's a way to control the intensity of the sun radiation. Now, Icaro mission used this concept because they wanted to control the attitude of the sail. So having different forces acting on the sail regulated by these devices will cause a torque on the spacecraft. Now, the idea we had in mind inspired from the MIT Origami robot, where we have this origami robot that is, let's say, folded using the magnetic field. This is the challenge. Our novelty is to study the self-folding mechanism for self-reconfigurable CubeSat. So imagine now, if you have a surface where those devices are distributed on the sail, and then we can trigger the folding by changing the effect of solar radiation pressure. How do we want to study and test this? We want to have this prototype done with additive manufacturing. So what we are interested is, let's say, in the support, where we are going to place these polymer dispersed liquid devices. So we are interested, let's say, in the soft mechanism that will allow triggering self-configuration. And then in the end, we would like to have a next generation of solar sail that allows a reconfiguration. So thank you for the attention. This is the proposed project, which we have a kickoff meeting today. So, well, I hope you find it interesting.